there. On this video, we are going to work on the try-it problems on page 10 and 11 of your Quarter 2 Algebra 1 notebook. Our focus is going to be graphing with intercepts and roots. So if I look at these questions, number 1, A, B, C, D, I'm just going to do 2 of these in this video. We are going to find the intercepts to graph lines. So remember, the x-intercept is the value of x when y equals 0. So when y equals 0 with this equation, I know that 3 times 0 is 0. So I end up with negative 5x equals negative 15. I will divide both sides of the equation by negative 5, and I get x equals 3. So my x-intercept is at 1, 2, 3, 0. My y-intercept is the value of y when x equals 0. So if x equals 0, I get negative 5 times 0, which is 0, and I will be left with 3y equals negative 15. I'm going to divide both sides by 3, and I get y equals negative 5. Now I'm going to be at 0, negative 1, 2, 3, 4, 5. I will take my ruler, draw a line, and add some arrows. Voila. Let's take a look at C. There is a fraction coefficient, but don't worry, I'm still doing the same thing. I'm going to find my x-intercept. So what is the value of x when y equals 0? Well, 1/2 times 0 is 0. So I will be left with 2x equals 2 divided by 2, both sides, and I get x equals 1. So when x equals 1, y equals 0. There's my x-intercept. My y-intercept is the value of y when x equals 0. 2 times 0 is 0. So I have 1/2 y equals 2. I know that with fractional coefficients, I'm going to multiply each side by the reciprocal. That will cancel due to the inverse property of multiplication. So y equals 4. So when x equals 0, y equals 1, 2, 3, 4. And this line looks like this. Add my arrows, and I am done. Alrighty, why don't you try A and D on your own and pause the video. When you're done, turn the video back on, and you can make sure you got the right answers. Alrighty, hopefully you took the time to look at letter A and D. With letter A, oddly enough, I end up with the same intercepts and essentially the same line with 4x plus y equals 4 to 2x plus 1/2 y equals 2. We'll be talking about these types of situations later on in the second quarter. When you have the same line, the equation looks different, but same line, coinciding lines. So here we have the value of x is my x-intercept here at negative 3 and my y-intercept at negative 4. Moving on to page 11, we are going to talk about this word problem because sometimes intercepts are a great way to solve a word problem. So you're helping to plan an awards banquet for your school, and you need to rent tables to seat 180 people. Tables come in 2 sizes. Small tables seat 4 people, and large tables seat 6 people. This is the situation this equation can model this situation. X is the number of small tables, so here's the small tables, and y is the number of large tables. So we're going to find the intercepts of the graph, we're going to graph the equation, and we're going to give 4 possibilities of tables I can rent. So let's find the intercepts. Let's find the x-intercept first, which is the value of x when y equals 0. So if y equals 0, 6 times 0 is 0, I will be left with 4x equals 180. I'm going to divide both sides by 4, and I am going to get, just put that in the calculator. What am I going to get? One moment. 45. So x is going to be at 45. Now my y-intercept will be the value of y when x equals 0. So if x equals 0, I'll have 6, y equals 180. When I divide both sides by 6, I get y equals 30. So I know that X is my value of small tables. So I'm going to label my X-axis as number of small tables. And then I'm going to label my Y-axis as number of large tables. Now, naturally, I could rent 0 of both. So there's my 0. It looks like I need to get to 45. So let's just see how many, if I count by 5s, 5, 10, 15, 20, 25, 30, 35, 40, 45, 50. Yep, I'm going to be able to get into 45. So I'm going to do 0, 5. I'm not going to write a 10. I'm just going to write 15, 20, 25, 30, 35, 40, 45, 50, 55, 60, 65, 70, 75. I'm going to skip so I just don't have the space for it to look good. Excuse me. Now for my Y's, I'll just be consistent and I'll count by 5s here too. So I have 5, 10, 15, 20, 25, 30, 35, 40, 45, 50, 55. Alrighty, I'm just going to erase that line so it looks all the same. So I know that when y equals 0, x is going to be here at 45. So I need 4 possible solutions, right? So one solution, if I have small tables and large, is going to be 45 small tables and 0 large. So my intercepts are possible solutions. Now there is my x-intercept. My y-intercept is also a possible solution. When x equals 0, I can get 30 large tables. So there is another solution. So what I'm going to do is I'm really going to use my ruler and really try to do a straight line as possible here. So hopefully I can maybe see some other solutions. It is looking pretty good here and here, but I've got to see if they actually work. So this is telling me x equals 25, 30, and this is telling me y equals 5, 10. Let's just make sure that works. So x equals 30. 4 times 30 plus 6 times 10. That is going to be 120 plus 60. 120 plus 60 is indeed 180. So that's, 180. So that's a check. Okay, so I know this works. Let's see about this one. This is x equals 15 and y equals 20. Let's just make sure it works. So I'm going to do 4 times 15 plus 6 times 20. 4 times 15 is 60, and 6 times 20 is 120, and that does equal 180. So it works. So my 4, here's the graph. I'll graph nicely. Here are my 4 possible solutions. And now I am done with this problem. Alrighty, we're just going to practice finding the zeros of some functions, and then we will be done with this video. So find the zeros of the following functions. There is no number 4. A. Looks like I am doing this algebraically. So I know I want the x-intercept, so the value of x when y equals 0. 6 times 0. So I get 1/3 x equals 18. Now I'm going to multiply each side by the reciprocal. And x is going to be 18 times 3, which is 54. So this particular graph crosses at 54, 0. This one looks, quite frankly, very graphic, and it looks like we are crossing here at x equals 0. So your root, or your 0, of this particular function, remember, zeros are x-intercepts. Zeros are also called roots, is at 0, 0. I'm going to set this equal to 0. So I have negative 3 plus 5x equals 0. Add 3 to both sides. I get 5x equals 3. Divide by 5. And this particular line will cross the x-axis at 3/5. So it will cross at 3/5, 0. Last but not least, I've got graphically here, it's crossing at -1, 2, 3, -4. And at 1, 2, 3, +4. So this crosses at -4, 0, and 4, 0. That's it for this video. Thanks so much.